Hello everyone, it's Jack back at it again. It's Jack, and today I have an interesting problem that I would like to solve with you guys. I have already solved this and I am here to present how I did it. So, this is something I'll be doing often whenever I find a problem and I solve it. I'll be sharing the solution with you guys. So, today's problem is finding the smallest natural number n such that the sum of the expression is superior or equal to 2022, our current year. So let's begin. So let's just first start off by writing what you have to prove. So we have our expression. So we have our expression. And how are we going to find the n value? So I suggest that we start with the left-hand side. So let's isolate the left-hand side. Let me just copy the left-hand side. So I have isolated the left-hand side and let's work on it. So to isolate it even more, let's remove the sum for now and only work on the equation. So we have this, which looks pretty scary. And it's something that we don't like because we have square roots here. We have square roots, but it's not the best thing to have. So how do we get rid of them? We are simply going to multiply the expression by its conjugate in order to get a simpler form. So the conjugate of what is highlighted is simply, so let's just say, no, I'm just going to put the conjugate and I'm going to put this down here and I'm going to multiply it. So this is equal to the square root of k minus the square root of k plus 1. And I'm gonna just rewrite the whole expression. Okay. Why? Because they just, let's say that I didn't want to have this. They just simplify out. I can put this in parentheses and simplify this and this, but you're not going to be doing that. So we have this, and why did we do this? This looks still as confusing as before. No, because we have an identity that says that a plus b, the factor of a minus b is equal to a squared minus b squared. And we can do this here. I'm going to isolate it even more. We're going to be isolating this. Of course, this is not the most optimal writing for this math problem, but it's just to allow you guys to see what you're doing. So our a here is this a. We have b, we have a, we have b. So we just use this and we get square root of k squared minus k plus 1, square root of k plus 1 squared. And they just simplify out. So we have k minus, in parentheses, not to make the mistake, which gives us minus k minus 1, which is simply minus 1. What does this mean concretely? This means that this is simply equal to minus square root of k, which gives us minus square root of k plus square root of k plus 1, which is much more digestible. So we can rewrite our summation as this. Okay, now that you have this summation, what can we do? What should we do? So let's just go case by case and see what happens. So sorry for the noises, guys. For k equal 1, we have minus square root of 1 plus square root of 1 plus 1 equals minus square root of 1 plus square root of 2. For k equal 2, we have minus square root of 2 plus square root of 2 plus 1 equals square root of 2 minus square root of 2 plus square root of 3. And let's just go one more time. For k equals 3, we have minus square root of 3 plus square root of 3 plus 1 equals minus square root of 2 plus square root of 4. So we are just going to be adding all of these and we will get the expression of this. So let's just rewrite it. I'm going to write the summation as small as I can to take up as little space as possible because this might be long. So we have this k plus 1, which is equal to minus square root of 1. I am leaving the square root to make you guys see what is going to happen. Plus square root of 2 minus square root of 2 plus square root of 3 minus square root of 3 plus square root of 4. And it keeps on going. Minus dot dot dot. And I'm just gonna put it at the nth term. So minus square root of n plus square root of n plus 1. Okay, so can you guys see what I wanted to make you guys realize? I'm going to put it in red. This, and this, they cancel out. This and this, they cancel out. So everything between this cancels out. So everything cancels out. And the expression that we remain with is, let me just put it back in black, n plus 1 square root of n plus 1 minus 1. Why is it 1 now? Because the square root of 1 is 1. So we can just simply write 1. Now that I've showed you guys what I had to show you guys. So we have our expression. I'm going to write the initial definition. We have this is equal to n plus 1 minus 1. So now we can just solve the inequality. So we have n plus 1 minus 1 superior or equal to 2022. We just add 1 to both sides, which gives us n plus 1 superior or equal to 2023. We square both sides to get rid of the square root. So n plus 1 superior or equal to 2023 squared. And we remove 1 to get n is superior or equal to 2023 squared minus 1. So the smallest n value is, and I'm just going to put n equal 2023 squared minus 1. So that was me. That was it. I hope you guys enjoyed the problem because I really did. And see you guys the next time. Love you guys. Bye-bye.